Welcome to the GOCO instructional video series. In this video you will learn about the filter selection section, which is found in a new or existing scenario in the scenario options section. In particular, we're looking at the subsection of filter selection. On the select filter drop-down menu, you will see in a moment that there are three different options: bag, cartridge and pleated. These are different types of filters. For the present case, we'll be using the cartridge filter option, as this is the purpose of this instructional video. If you haven't done so already, please start your version of the GOCO program. Once you see the home screen, such as this, navigate to the top bar menu and click on New Scenario. You may select an existing scenario from which to work, but it will be much easier to start anew. We click on New Scenario, then appear the configuration for a scenario. We'll be looking at scenario options in particular. Before the filter section appears, we will need to fill in details before that, such as valve selection. For the purpose of this example, we won't be solving it, but let's select a solve mode in any case. We'll use calculate outlet and or header sizes, GOCO 7.2 equivalent, when the header size and also the orifice size are unknown. Now we'll select a typical valve. We'll use the RCAC 20T4. Then appear the two fields of electrical on time and the remote pilot line length. A typical value for the electrical on time is 100 or even 150 milliseconds. We will use 100 milliseconds for this example. We will also use a remote pilot line length, the recommended length, of 1 meter. Then we come to the header selection section. Since the header volume is unknown, we'll choose solve for header volume and input a typical pressure of 600 kilopascals. The header temperature can remain unchanged. You will notice now that the filter selection section has become visible. The first drop-down menu in the filter selection section is, as mentioned earlier, the different types of filters. We have a bag filter, a cartridge filter and a pleated filter. As mentioned for this example, we'll be using a cartridge filter. Once that is selected, the first input field to appear is cartridge diameter. Any used cartridge filter diameter may be entered that is specified by the customer. A typical cartridge filter diameter that is used in gas turbine intake filter systems is 9 inches or 225 millimeters. So let's put in the value of 225. Please take note that if you do switch units from millimeters to inches or inches to millimeters, the value will not change. That needs to be manually changed. We'll go back to using the metric system. The next selection is the drop-down menu, which has two different options to specify the filter performance. That is the filter area and the air to cloth ratio, or the direct method of specifying the filter design flow rate. For these two options, we will look at in particular what is involved. If we choose to use the filter area and air to cloth ratio, the first option, then the filter area is only for an individual filter, or in the case of gas turbine intake filters, this could be a stack or set of filters. For example, there could be a straight and tapered filter stacked on top of each other to form a single filter set or stack. The filter area would be the combined area of the straight and tapered filter. Another way to think of filter area that is quite useful is that the filter area that is cleaned by an individual orifice from the blow tube. The air to cloth ratio, the other parameter there, is usually given by the customer. Now, if the customer specifies the total filter area, then the number of filters must be known in order to divide out the total filter area to calculate the area per filter, which is what needs to be put in the filter area field. Now, if we choose the second option, filter design flow rate, the volumetric flow rate and the individual filter volumetric flow rate in particular is specified by the customer, then this can be input directly into the field using appropriate units. If the total volumetric flow rate is specified by the customer, then again, like the total area, this needs to be divided out by the number of filters in order to obtain the volumetric flow rate per filter. When the values for either the filter area and the editor cloth ratio or the direct method as just shown using the volumetric flow rate have been entered in the appropriate fields, then the filter forward flow will appear calculated in the bottom of this section. That's this box here. For example, if we were to use the filter area and the editor cloth ratio, and we use now typical numbers for the filter area, let's say 33 square meters, and a typical value for the editor cloth ratio, 0.02 meters per second, you will notice that the filter forward flow has been automatically calculated. This is not an input field, it is a calculated field. That is 660 liters per second. Now, if we use the direct method of filter design flow rate, then if we have that specified by the customer for an individual filter, or as mentioned earlier, the total filter flow rate divided out by the number of filters, then we input this value directly. So let's use the previous example, which is 660 liters per second. You will notice that the filter forward flow is identical, 660 liters per second. So let's leave this value in for the performance of the flow through the filter. The next field to be input in the filter conditions section is the pressure drop. That's this section here, or this input field. The pressure drop is the difference in pressure between the incoming dirty or particulate laden air and the cleaned or filtered air passing out of the filter house or filter assembly. The pressure drop is identical between the inlet and outlet of the filter house and that from the dirty to the clean side of the filter house. Another way we can think of it as merely the pressure difference between these two extreme points in the filter process. The differential pressure is that pressure difference that results from the resistance to the flow by friction with boundaries and other flow obstructions, but mainly results from the pressure drop from the particulate buildup on the surface of the filter. A typical value that is used for cartridge filter applications is 1000 pascals. So we can put that in the input field. This completes the filter selection section and the setup for a cartridge filter case. Yes, it's as simple as that. There will be other filter cases such as using a venturi on a cartridge filter, or possibly having 2 or more blow tube orifices pulsing into a single cartridge. You might have encountered those cases in the past. That will need to be set up differently using GOCO8. For these cases, it would be advisable or recommended to contact the GOCO8 engineering office. Now this completes this video in the series, and as always we hope you enjoy your GOCO user experience.